I'm Diana, the founder and the CEO of Xatoms. Water is a huge part of our lives. When I was 14, I went backpacking Asia with my mom, and that's when I for the first time ever saw black rivers. I decided then and there to dedicate my life to solving this problem. At 17, I used quantum chemistry software to discover my very first molecule of a water cleaning material, winning the world's most prestigious water award from the Swedish royal family, thanks to which I received full Pearson scholarship to study computer engineering at the University of Toronto, which brought me from my small village in Slovakia all the way here to Canada, where I started Xatoms. The problem is that current filtration solutions can turn dirty water into clear. However, this clear water may still contain invisible contaminants such as heavy metals, biological pathogens, killing millions of people every single year. And this is not a problem happening far away from us. Just outside our door in Ontario, where I came from, Indigenous communities still lack access to clean and safe drinking water. In fact, this is a nationwide problem here in Canada. Indigenous communities are exposed to polluted water from the time they are born for their entire lives. Some of them have to drink polluted water, which contains 10,000 higher levels of E. coli than is allowed. At Xatoms, we're solving this problem by discovering new materials called photocatalysts. Here is a clean water. I'm going to pollute it with a toxic methylene blue. So photocatalysts, when added to contaminated water and exposed to any visible light source, such as LED, in our case, can turn this dirty water into clean and safe drinking water within under 30 minutes, or by the end of the presentation because of the low concentration that I've used. This is what it looks like in the lab. We have a highly concentrated polluted sample, and after 10 minutes and after 30 minutes, it's a clean drinking water. It's been 7 years since I won the award in Sweden. I've been working on this research extensively. With 7 years of R&D, we developed a patented process which uses a combination of AI and quantum chemistry to computationally discover new materials of photocatalysts. We have a 40 times faster process because of the combination of quantum and AI, and we target different photocatalysts for different contaminants. So far, we discovered 8 patent-pending photocatalysts, each of them cleaning different types of contaminants, from chemical pollutants such as DDT to biological pathogens such as E. coli and cholera. And with these 8, we can already prevent 3.5 million waterborne deaths, but we are on track of discovering over 150 more photocatalysts in the next 3 years. We are currently manufacturing our photocatalysts in a lab in Toronto, as well as Kingston, Ontario. However, we are using a standard lab process, which allows us to manufacture on the spot and the location of our pilots, making our manufacturing process highly scalable. We are part of a huge $500 billion market, positioning us to become the next unicorn in water. Our materials are 4 times more effective because of the targeted approach, because of the computational methods we use, as well as they are 2 times cheaper, because they can be applied as coatings on surfaces, and these coatings can last an entire year. Compared to chlorine, which can eliminate pathogenic germs, we can do all of these 47 contaminants, as well as pharmaceuticals, dyes, which are found in the developed world. When we were commercializing our products, we spoke to over 200 stakeholders, some of the biggest names in the industry, such as Xylem, that told us about their pain points. For example, they cannot remove specific contaminant from water. It takes too much energy, too much time. And Xylem was actually so interested in us that they've introduced us to current small pilots to first test our technology before we go industrial. And we are currently selling our materials as a B2B. And last year, we were able to hit an important milestone when we received our NSF 61 license and all the regulatory licenses. And we were actually able to bring our technology from the lab to the communities that need us the most. And we currently have $1.5 million in signed contracts, pre-orders. One of our clients, Pureback, so they provide the filters, we provide the powders, and they coat the filters. We've coated 10,000 of these filters already. This is a consumer type of a pilot. Xylem introduced us to our community pilot in Kenya, where we spent 3 months last year, as well as we have an first industrial pilot in South Africa. And we're working on heavy metal removal with indigenous communities. With these 3 pilots, we are generating $1.5 million and impacting 163,000 people. This is Tsuut'ina First Nation. Children still have to shower in yellow water. Aren't we tired of this? It's 2025, still going on, just outside of Calgary. And well, at Xatoms, we have a solution because our photocatalyst actually can neutralize these dissolved heavy metals, which are charged and invisible, and they can neutralize them and turn them into solids, which can be later filtered out. As well as, with Canadian Natural, we have in pipeline $18 million contract for 2026 and 2027. And we recently started collaborating with Water.org, co-founded by Matt Damon, which is going to help us reach even more communities. Our path to $100 million includes finalizing our current pilots, expanding to the industrial applications with partners such as Xylem, Canadian Natural, and eventually hitting $100 million by 2030. We just recently closed our pre-seed round, and we've hired 6 full-time employees, so we are currently 10 full-time employees. We have experts in photocatalysts, AI, we have PhDs, we have masters, all 3 co-founders, full-time students. We are all on full scholarships. I have a background in computer engineering and computational chemistry. Our CTO has quantum background, our CEO has software and business background. We're the youngest on the Forbes 30 Under 30 North America 2025, and I'm the youngest Canada's Clean 50 emerging leader. We're advised by world-class scientists, such as the head of climate tech at AWS, head of chemistry at the University of Toronto, head of water at the United Nations. And we've raised $2 million in pre-seed funding, led by Quantaset. We have a funding from BDC Thrive Lab as well. We started initially with angel groups, and we raised over $400,000 in grants. Our biggest grant came about 2 years ago from Alexis Ohanian, the founder of Reddit. And this $10,000 from this competition is going to go towards purchase of a furnace, which is going to enable us actually manufacture our photocatalysts on the spot for an indigenous community in Northern Ontario, which is going to help us manufacture from 1 kilogram per day to 4 kilograms per day, and 4 times higher volume. 4.4 billion people today still lack access to clean, safe drinking water. With Xatoms, let's make it 0. Thank you.
We will now begin a question and answer period. Judges, please raise your hand if you have a question, and a microphone will be brought to you.
Over here on your left. Over here. Hi. How do you, if you get this out to a community, how do you train them on how to use it in a safe manner if you're trying to scale up the business for individual use?
Yeah, I'm just going to quickly go to the slide. So for the process that we are using is we usually takes around once we get the pilot, it usually takes 1 month to produce a sample and send it to the community. And then we do a full-scale installation for 3 months. So we train the water organization that we work with how to apply the filter, how to apply it as a coating. So for example, in Kenya, specifically, we're working with Water Kiosk, and they are a franchise. So we started with 1 water kiosk where we spent 3 months in Kenya, and then they have expanded to 50 other kiosks within that year. So it's basically like a scalable process where we start with one kiosk and then we continue expanding.
Diana, a great presentation there. I have a question. Do you have a system integrated into your process to validate your quality control system, proving that you have a pure water sample at the end?
Yes. So when we start with our computational methods, so the AI is used to analyze if the sample is safe for human consumption. That's initially. We are dealing with a huge data set initially, and then when we get to the final candidates, we know they are safe, but at the same time, we test the photocatalysts with UV spectrometer. So this is all the testing that we've done. Like we tested UV spectrometer, we tested the coatings, and the system is actually measuring intensity of light. So we have this tiny solar panel, which is used in a system, and it's measuring how much light has passed through. So it's actually going to be safe for like the light intensity.
Hi, thank you. The precipitate that comes out after treatment, what are the plans for the waste management that happens with the solids that are resolving post-treatment? Whether it's in situ in a reservoir or in a manufactured facility, how do you work with communities and/or end users to responsibly manage the wastes that are ultimately generated?
Yeah, can we please go to technical mining project? So with the community, so we focus on invisible contaminants, first of all. When we are not dealing with heavy metals, these invisible contaminants, we degrade the contaminants. Our photocatalysts actually attack the bonds of the contaminants and make these byproducts, which are safe for human consumption. However, if we are dealing with heavy metals, this is the project with Canadian Natural. So we are applying Xatoms photocatalysts directly to the tailing ponds, and then we are filtering out the heavy metals and contaminants. And the heavy metals can be recycled. They can be used for different types of manufacturing. And then that's usually, our client usually deals with the residuals. So our main value proposition is removing them, and then they are dealing with them.
Hi there, that was great. I noticed, and I'm not sure I care, the revenue is really good, but I just want to see if there's another client you want to talk about. Because you told us about 1.4 million in revenues this year, but your paper says 4.3. So I was wondering, is there another client in there that from 2026 that's forward, or is there somebody else you want to tell us about?
Yes, actually, let's go to, I'm just going to go to these pilots here. So these three current pilots, the $1.5 million, that's already being executed. So we've started executing in December, and they're executed for 8 months. So we'll be finalizing around in June, like next month. And then the pilot in South Africa is like, we have an add-on pilot with $2.8 million that's coming after the execution of this current pilot. And then with the Canadian Natural, we are planning to have a schedule where they will pay us also upfront.
On your left here. I just wanted to, first of all, impressive presentation, and sounds like you've hit every single government body, celebrity out there, so kudos to you. I just wanted to ask you about kind of risks there. So you talked a little bit about compliance, maybe scaling production and maintaining the quality, legal implications. What are some of the risks? I didn't see you kind of really identify them there for your business.
Yeah, so we initially didn't know how to start talking to the customers. So that was a long process, which took us an entire year last year. And with the indigenous community specifically, we wanted to be as respectful as possible when approaching them. So we have taken courses and we've read a lot of reports, and we also hired an indigenous full-time person on our team, so they can actually help us penetrate within the communities and create the relationships. So there might be some like cultural differences, risks, which we wanted to be as respectful as possible. And then also, interesting thing happened. We just hired 6 full-time employees, and some of our employees are 3 times older than us. So it's very interesting to manage people who are 3 times older and be their CEO. So that's been very, very fun process. Yeah.
Over here. Curious, when you get to 100 million, how does this not implode? because you've got all these wonderful advisors. I'm just not necessarily seeing the structure in place yet. Would you walk us through a little bit more of how you're going to keep this growing and scaling as all of these wonderful things happen?
Yep. Let's just go quickly here. So the path to $100 million includes we want to become a leader in the photocatalyst discovery industry. Eventually, we understand there is a lot of systems going on and a lot of different projects. We want to have this, our biggest power is the software that we create, and we would like to eventually just sell the molecules to the clients and then figure out how to apply the photocatalyst. So our goal and our dream is to be a leader in the photocatalyst space.
Do you want to bring us back to your sample on the table there?
It's very tasty.
Hi, great presentation. Hopefully there's time for me to get this question out, but I'm just curious about the data that you're collecting from the samples themselves and what you're doing with that data, and if there's another business model in there, if there's something that can be done with that data to help these communities. Obviously, you're getting lots of interesting information.
Yes, so we started our in-house built AI algorithms, the ones that are patented. We have over 850,000 molecules, so we hold the highest data set of photocatalysts in the world right now. And with those, we were already able to generate the photocatalytic molecules that you see here. However, we can always improve the model. We started with some of the contaminants such as E. coli. But our goal now is going to be focused on actually specific forever chemicals, pharmaceuticals, and this will require actually higher amount of data because they have very complex structures. So our goal is to collect the data from our current pilots and then come back and then train our model to focus on like the toughest contaminants, which are forever chemicals, so they are forever. But we want to eliminate them with our photocatalysts. Yeah.
I'll be fast. Is the profitability that you're seeing different? Oh, I'm over here on this side.
Okay.
The profitability different for the different types of projects?
Exactly. So let's talk about the pure back filter. So our clients provide us with the filter, or basically we provide them with the photocatalyst, and this is what the filter looks like. So we have a 70% margin on this specific filter, and it costs around $2.5 to make, and then $4.5 is the profit on each filter.
Your time has expired.
Thank you.
Judges and guests, please help me in thanking Diana.